Welcome to the Live to 110 podcast. My name is Wendy Myers, and you can find this video podcast on my website on live to110.com on the blog post, or on my YouTube channel, Wendy Live to 110. Today, I'm really excited. We have Dr. Nick Ralston on the podcast today. He is a researcher on mercury and selenium. He has over 70 publications where he has written about mercury and its effects on the body and with pregnancy, etc., etc. And so we're going to be talking about whether or not you should be avoiding fish due to mercury concerns. But before we get on with the program, please keep in mind that this program is not intended to diagnose or treat any disease or health condition and is not a substitute for professional medical advice. Please consult your healthcare practitioner before engaging in any dietary recommendation we make on the show today. Dr. Nick Ralston leads research programs involving human and environmental health. His group's current investigations involve evaluating human health effects and risks associated with environmental contaminant exposures and effective remediation and other approaches to reduce environmental health risks. His Ph.D. in Biomedical Research Biochemistry is from the Mayo Medical Center in Rochester, Minnesota, and his principal areas of interest and expertise include the full range of mercury toxicity, with a primary focus on its effects on selenium interactions and how these influence quantitative assessments of potential pathological effects of mercury-selenium interactions on all levels. His primary interests are the pathophysiology of toxic trace element exposures, as well as prevention, protection, and remediation strategies. His current research interests include examinations of the molecular mechanism of methylmercury toxicity, selenium-dependent biochemical processes involved in the neuro and cardiotoxicity of mercury, as well as mercury phytoremediation and other means of diminishing bioaccumulation of mercury in freshwater fish. Other interests include continuation of his work on the biochemical mechanisms of pulmonary particulate pathologies and studies of the physiological basis for the beneficial effects of omega-3 fatty acids in cardiovascular and neurological health. Wow, that was a tongue twister of a bio. So, Dr. Ralston, thank you for coming on the show.
I think I'll work on shortening my bio. I think that one reads better than it works as a read out loud form. But
yeah.
Oh well.
Yeah, I thought that I did shorten it, but apparently not enough. But at least we know a lot about you. We know that you are very entrenched in the research and very knowledgeable about this subject. So why don't you tell the audience a little bit about how you got into, is so passionate about researching mercury?
Okay. Well, my background, I've been in nutrition research since the late 70s, and my training at Mayo was all about molecular mechanisms of disease. Mercury, because I understood selenium physiology and how important it is in the brain, I transferred from nutrition research to toxicology because it was completely obvious that mercury impairs selenium metabolism. It just lined up so well. I mean, everyone knows that mercury's got a high affinity for sulfur, but it's really obvious, just based on chemical first principles, that mercury would have an even higher affinity for selenium. And as it turns out, everything about my initial assumptions we have validated and found to be true. The only thing that we did not confirm was when I moved over to working in toxicology, it was because I thought that eating ocean fish was causing severe brain damage to children. And that was the reason I moved over. I saw this as one of the biggest problems there is on Earth. Nobody wants to have children getting harmed, and so that's how come I made the career change. However, when I got into the issue, I started finding out that ocean fish, all of the ocean fish I was looking at, had tons of selenium relative to the mercury, and since one mercury can only steal one selenium, that didn't add up. What I found later was the forms of seafood that were being consumed that were causing harm was not typical varieties of ocean fish at all. Just like all other Americans, I assumed that if we're being warned not to eat ocean fish, it's because studies had found ocean fish were causing trouble. Unfortunately, that assumption was not correct. We can go into that in response to one of the next questions.
Yeah, I mean, that's the problem with researching elements in isolation, which many nutrients and metals are. It's more complicated. You have over 70 publications on the effects of mercury. Can you tell us the effects that mercury has on the body and the health conditions to which it contributes?
Well, this is really kind of exciting stuff. It's a great time to be in selenium research and in mercury toxicology. It turns out that what selenium does in the brain is protect it against oxidative damage. The aging process, and actually we're all aging, I mean the alternative to aging is not a good one. We're all aging and gradually declining because oxidative damage is accumulating. In the brain, where the tissues consume about 10 times more oxygen on average than the rest of the body, the free radicals and reactive oxygen species that are generated by that much oxygen consumption would really tear the brain apart very rapidly if it didn't have exquisite, elite enzymes protecting it. Those elite enzymes are selenium dependent. It turns out that although most people that hear this broadcast are going to be familiar with that there's 20 amino acids in most proteins, it turns out there's 21. People have overlooked selenocysteine. There's only 25 enzymes or proteins expressed in humans that have selenocysteine in them, and that's how come it got overlooked for so long. But we've known about selenocysteine and its importance in these enzymes and a host of others. The 25 selenoenzymes that are expressed in humans, they have hugely important functions like regulating thyroid hormone status, controlling calcium influx in and out of a cell. But probably the most important one that pertains to what we're talking about is the protection against oxidative damage. For instance, like everyone knows, vitamin C is important in protecting against oxidative damage. Most people, however, are not aware that vitamin C would only be good for a single time of controlling oxidative damage if it wasn't immediately recycled back into its active form by a selenoenzyme. So vitamin C would be no good without selenoenzymes. A host of other antioxidants would only perform their function one time if selenoenzymes didn't restore them to their active form. So selenoenzymes not only do that way of protecting our tissues against damage, they actually directly protect the lipids, the proteins, the DNA from oxidative damage and can reverse oxidative damage to lipids and proteins. So without selenoproteins, well, we wouldn't live very long.
Yeah. So are you an advocate of supplementing selenium or getting it just from fish?
Well, nutritionally, if you're really in a place where your food doesn't have enough selenium, supplements might make sense. But in North America, most of our foods are so rich in selenium, we don't really encounter selenium deficiency. In fact, that might be part of the reason why people are not aware of selenium's importance in the United States and Canada, because all of our foods are so rich in it. Nobody over here is ever selenium deficient. Yeah. However, in some parts of China, people die in their 20s from a cardiomyopathy that occurs because their bodies do not have enough selenium. And certain viruses capitalize on selenium-poor hosts and can take them out and kill them rather quickly. There's a whole bunch of interesting stuff on that today, but we're talking about ocean fish.
Yeah, we're talking about fish. Yeah.
Ocean fish, that's a really nice package because it has the omega-3s, it has a host of other fat-soluble vitamins that a lot of Americans are poor in, plus the form of selenium that's present in ocean fish. It's a form that you can only get from ocean fish. It's known as selenoline, and that form of selenium is actually kind of unique. We've only known about it for the past few years, but that is a very important antioxidant form of selenium that, along with all of the selenoenzymes that I previously described, contribute to protecting the body against oxidative damage. So ocean fish I would recommend, especially for a pregnant woman, because the developing child's brain needs the long-chain fatty acids because that's what the brain is primarily composed of. if a woman doesn't get enough of the long-chain fatty acids from eating whatever's in her diet, like ideally ocean fish, she will actually go to the next best source she has of omega-3 fatty acids, and that's her own brain. She will rob her own brain of her omega-3 fatty acids to assist in the development of the child's brain. So I would suggest eating ocean fish just to avoid baby brain and postpartum depression, things like that. We're still nailing down all of the connections, but it appears that that's actually going to be an important aspect of the seafood consumption issue.
Yeah, I was definitely a poster child for mommy brain because
Oh, really?
you know,
Okay.
I loved sushi. I loved eating lots and lots of fish every week, and had to stop eating that by my doctor, per my doctor's advice.
Yeah.
Stop eating fish, except for maybe once a week, and you know, I think a lot of women suffer as a result of that.
Yeah, that's one of the worries. It's hard on the mom, and I was just at a meeting of the EPA about 3 or 4 weeks ago, and the consensus opinion of that meeting, this is all of the mercury researchers across the nation, the consensus opinion of that meeting was eating ocean fish improves child IQ by 4 to 6 IQ points. Some of us believe in the United States our moms might be so DHA deficient that it might be even more than that. But currently we're saying 4 to 6. And it's all benefit. We're not seeing any negative effects in any of the studies on women that are eating ocean fish.
Yeah.
Those studies that found adverse effects, they were not eating ocean fish. They were eating whales. Well, shark is a type of ocean fish, but who eats shark?
Yeah,
I mean,
yeah.
yeah, I've never eaten shark. Maybe some places it's on the menu, but I
Yeah.
certainly have never had it.
So let's talk about the other side of the coin, the mercury toxicity. What is the prevalence of mercury toxicity in the population based on your research?
Okay, the thing that we're aware of regarding mercury toxicity comes from the studies in Minamata. Minamata, Japan had a factory that had released tons and tons of mercury into a very small bay. So the fish in that bay, they were ocean fish, but it was a very restricted in and out to that bay, so the mercury accumulation in those fish was extraordinarily high. Mothers that ate that had severely harmed their children. In fact, it was even harming adults. One thing that's really common and understood throughout the mercury world is that babies are particularly vulnerable to mercury exposure. Adults, well, we now know the reason why is adults, we've got a ton of selenium in our brains, so if mercury comes at us, well, we lose a few seleniums, but we've got a ton of of selenium to offset those losses, so we're not harmed. But a baby doesn't have any selenium reservoir at all. Its cells are dividing so fast that it's just on the ragged edge of keeping up with having an adequate amount of selenium and all of the other nutrients. But if you're having mercury come at the child from, like, if a mother's consuming like whale meat or shark meat that contain several times more mercury than selenium, or even worse, the fish that were from Minamata Bay, which had something like 50 mercuries for every selenium, eating that is of course going to be harmful because the baby's just barely getting enough selenium as it is. Now a pile of mercury is coming in, sequestering the selenium before it even gets to the baby's brain, or the mercury gets to the baby's brain and then sequesters what selenium has arrived. That's a recipe for disaster. And children being harmed, it's completely consistent with how we understand selenium's role in the whole issue. But as far as mothers being harmed from eating other types of ocean fish, in the United States, there's probably very, very few places where anybody is eating types of fish that have more mercury than selenium. I mean, swordfish can be a problem. If there are mothers that are eating shark, they should definitely stop because shark is not a very safe food to eat. No mothers in the United States eat pilot whale. But all of our warnings about whether or not it's safe to eat ocean fish come from a study where 85% of the mercury came from eating pilot whales.
Yeah.
In fact, the interesting thing about that study is that if those mothers had not been eating ocean fish where they got almost 80% of their selenium, the babies would have been severely harmed. Ocean fish actually prevented the effects of mercury from whale meat consumption from being as severe as they otherwise would have been.
Yeah.
So we're currently Well, no longer. I say currently. As of just a month ago, we're now turning around on this issue, and we're trying to get the word out more intelligently so that women will understand they should be eating more ocean fish during pregnancy instead of avoiding it. And even if you look at the text of the 2004 advisory, it did say women should eat up to 2 fish meals per week. But then it kind of scared everybody because it was saying, well, mercury's a neurotoxin and there is some mercury in the fish. And so every mother would say, well, I'm not going to eat any fish because it's a neurotoxin.
Yeah.
So it was this misunderstanding about how mercury caused harm. But over the past 10 years, we've figured out the mercury issue. We've made tremendous progress. We understand the issue so much more than we ever did before. And all of the studies that appeared to be in conflict, everybody was saying, well, this study found harm and this study found benefit. One of them's got to be wrong. No, both of them are completely right. Mothers that were eating seafoods that had a lot of mercury relative to selenium, there should have been harm. Harm was found. That's consistent with what we'd expect. Studies where the moms were eating normal types of ocean fish that contained a lot of selenium, relatively little mercury, no harmful effects, but benefits from omega-3, possibly from the selenoidine. Beneficial effects would be predicted to be seen. They were seen, so completely consistent, even though they appeared to be in conflict with one another. The issue makes a lot more sense now than it ever has before.
Yeah, yeah. And so what effect exactly does the selenium have on the detoxification of mercury? Like, how exactly does that happen? And does it also get the inorganic mercury that's from amalgam fillings?
Well, the way that it used to be thought was that selenium somehow or another scavenged up the mercury and kept mercury from causing harm. The harmful effects that had always been seen was if you have a high mercury exposure, you start having oxidative damage to the brain. It was thought that mercury was actually causing damage to the brain. It actually is not at all the case. Mercury sits there rather innocuously in the brain. However, if it steals your selenium, and there's no more selenium left to keep those enzymes protecting the brain against oxidative damage, all of a sudden you start having oxidative damage, not because the mercury is causing it, but because the mercury took out the selenium-dependent enzymes that normally prevent oxidative damage. So it's a very distinct turnaround. It's not selenium protecting against mercury toxicity, it's mercury sequestering selenium and preventing it from protecting against oxidative damage that otherwise spontaneously happens.
Yeah, yeah. And so, what are the fish that are highest in selenium, and what fish do you think generally should be avoided? You know, aside from pilot whale.
Well, yeah, any woman that's eating pilot whale should definitely stop right now, even if they're not pregnant. But shark is definitely one that more or less consistently should be avoided. There are some types of shark even that do not have more mercury than selenium. But until we get it very much nailed down, I think it's just safer for women to avoid all shark during pregnancy. Swordfish, they're kind of an interesting case because certain swordfish are fine. They've got plenty of selenium relative to mercury, but others, possibly older swordfish, have a lot of mercury relative to selenium and can be as troublesome as a shark. So swordfish is just good to avoid because we cannot guarantee that it's safe to consume. Oddly enough, although tuna and a bunch of the other types get in trouble because they supposedly have high mercury, their selenium is so much higher than their mercury. Those have some of the best mercury, or I guess it should be selenium to mercury ratios there are. They have so much selenium relative to the mercury that rather than contributing to causing harm, mothers that eat those types of seafood are better protected against mercury. And one of the things that we've been recently finding out, a study that was done in England with, let's see, I think it was 14,000 mothers. It was a very large study, 14,000 mothers and their children. And the children are now in their 20s, so this is a long-term study. They know how much ocean fish the mothers were consuming during pregnancy and throughout the life and the child's life. So they followed the ocean fish consumption throughout the entire period of study. They found that the more ocean fish that were consumed, the better off the children were doing as far as IQ, scholastically, socially. And this was one of the best studies ever done as far as eliminating confounders, because confounders are the bane of almost all scientific studies where, okay, we found this association, but then, well, was that association really real, or was it just that paralleled something else? In this case, it's called the Avon Longitudinal Study of Parents and Children, or ALSPOC is the short name. Just a great study. They found these tremendous benefits of eating ocean fish. And probably that study is the closest to an American cohort that we can have. Certainly it's the biggest study of its type ever done. And the more ocean fish that were consumed, they were eating, many of the varieties that we consume in the United States. They also eat a lot of whitefish and oily fish, that sometimes we don't consume but maybe should. Some of the oilier fish, they taste more fishy. Americans go, ooh, it's fishy. And, we just didn't grow up eating fish, so we don't know what's good for us.
Yeah, yeah.
We'd rather have a hamburger.
Yeah, yeah. I know. I always tell my clients to eat the really gross fish that no one likes, the mackerel and sardines and things like that.
Yep. Nice and oiled. It has the high omega-3s, and so it's all good. But yeah, because it's got that scent of fishiness, some people are not so happy with it. But really, I think we've got to grow up and understand the benefits are there. And yeah, it smells like fish. It's a fish.
Yeah. And so what about freshwater fish? Are those okay to eat? Because there is concerns about mercury and other things in some of the lakes and the rivers, and lots of pollution in the rivers from corporate runoff. And are these fresh fish safe to eat? I mean, aside from the mercury levels, I mean, there's definitely other toxicity concerns.
Well, I can only pretty much comment only on the mercury, but from the mercury perspective, mercury and selenium, we've done a study now where we had approximately 14,000 ocean and freshwater fish that we assessed or compiled the data of mercury and selenium on. The fish from 97% of the watersheds in the United States, or North America actually, were doing fine. But that means in those few cases that are not in the good bunch, we should be careful, because the amount of mercury, if it is in excess of the amount of selenium, and a mother is consuming that on a consistent basis, that could be very bad. And you have to remember that our current warning about what is safe to eat is based on a population where they were eating a lot of ocean fish, so they were getting a lot of selenium-rich food. We might not have the correct reference dose for a mother that's eating freshwater fish. If she's not eating ocean fish along with it, we've got really no idea how much mercury is safe for her to consume. So we've got a lot of work to do in the mercury issue, not only identifying which water bodies might be problematic. Like I said, most of them are going to be fine, but those that are not, we have to understand them far better. Plus we have to understand that the reference dose established on a whale and ocean fish eating population has no resemblance to what should be established for a freshwater fish eating population. A far lower amount of mercury might be far more problematic if they're eating only freshwater fish. For instance, we know of some tribes where they eat considerable amounts of fish from just their local area. And if they're not getting selenium-rich foods from other aspects of their diet, they might be at very much accentuated risk. And it's not just tribes. There's a lot of people that just like to go fishing, and they go to their lake regularly, and maybe that's a major source of their protein and their food. So if they are eating from one of those lakes in the 2 to 5% that I'm mentioning, they could be in trouble if they're eating too much from that one area. And we do know a lot about where selenium distribution is good versus bad. One of the things that's very important for people to realize is low pH restricts selenium availability. So even if the selenium is present in the soil, and in many parts of the United States it's almost absent from the soil, so this is after considering how much is in the soil. Even if it's present in the soil, if there's a low pH, and we have many areas that have acid rain issues, the low pH will keep the selenium from being available to the plants. And if the plants don't get it, the fish won't get it. It has to start with the plants, and yeah, under acid rain conditions, plants do not get the selenium. So we have some areas where there's high levels of mercury accumulated in the fish, and we know that there's an inverse relationship between the amount of mercury and selenium in fish. If it's a very low selenium area, we see an accentuated amount of mercury accumulate in the freshwater fish. On the other hand, if it's a very rich selenium area, the amount of mercury that's present in the fish goes down, in some cases, nearly to trace amounts. Great big fish that should have like almost 1 ppm mercury, almost no detectable selenium, mercury in it because it was such a selenium-rich lake. So very important work that needs to be done, and we're pushing forward on that. I'm going to a meeting next week where we're going to be discussing this and trying to get environmental scientists from across North America involved in studies of mercury and selenium. We're calling it the North American Sample Study, Selenium Alleviation of Mercury Polluted Lentic and Lotic, that's lake and river ecosystems. And it's a very important process that we're going to undertake. It's going to take a fair amount of time, but once we're done, we will have identified places where people should be very careful about eating ocean fish, or excuse me, freshwater fish, versus those areas where they should feel completely safe. But once again, this is only talking about the mercury aspects. I can't talk intelligently about the some of the PCB issues. If that's present, then that's a separate issue and needs to be considered in addition to the mercury.
Okay. And isn't there a problem with mercury toxicity, entering our water sources from coal burning here in the U.S. and certainly from China? I've read articles and some studies that there is precipitation of the mercury coming over from China and getting in our well water and other water sources. Can you talk a little bit about that?
Yeah, it's not so much in the well waters. It's probably more in like the river waters and lake waters. But mercury, once it's volatile, it can remain atmospherically suspended for a considerable amount of time. And even if it does precipitate into the ocean, one of the interesting things about solar activity, if mercury is just precipitated and is in the shallow portion that still gets a lot of sunlight, it can once again be photo-reduced and return to the atmosphere and hop and skip its way around the planet. It's been said that if we spent just a tenth as much as we currently spend on mercury capture in the United States on getting the Chinese to capture their mercury, we'd actually get far more mercury reduction in the United States. But what congressman would ever get reelected if he said, okay, here's what we're going to do. We're going to spend all our money in China to knock the mercury out. He wouldn't get elected.
Yeah, no.
So it would be a rational approach, but it just won't happen.
Yeah.
Mercury releases, there's one thing in power plants. Initially, they thought that the region of a power plant would have higher mercury in the fish. But there's an interesting thing coming out of the power plant smokestack. Right now they try and capture as much mercury as possible, and they're getting better at doing that. Our research center is a big one on how to capture mercury and keep it from getting out of power plants and anything else. But one of the interesting things is, in addition to mercury coming out, there's a large amount of selenium that comes out. Selenium precipitates really close to the power plant, and because of that, there's actually less mercury in the fish close to a power plant than there is farther away, because the selenium takes the mercury out of cycling, and so it's kind of the exact opposite of what people had earlier expected. So, like I said, it's a very exciting and interesting time to be studying mercury and selenium. The one takeaway that everybody that I've been talking to recently, and I'm talking to increasing numbers of people about this these days, is that it's impossible to understand the mercury issue without understanding selenium physiology relatively well. It all makes sense if you understand selenium. Otherwise, it's so difficult to understand if you don't understand selenium. And while it sounds complicated, really, if you just think about how important selenium is in the brain, and that mercury can sequester some of the selenium, but that ocean fish give you 20 seleniums for every mercury you get, so even if one mercury takes one selenium out, you're still 19 to the good. That explains so many aspects that people previously were just going on old assumptions, imagining, well, somebody's got to be wrong. It can't be that eating ocean fish of one type is good for you and ocean fish of another type is bad for you. Well, actually, it can. If you're eating shark or whale meat, that mercury is going to be very bad because you're not getting any selenium to make up for the amount of mercury sequestration that's taken away from you. If you're eating other types of ocean fish where you're getting 20 seleniums for every mercury, how can you get in trouble? It takes one away, but you're still 19 to the good, plus all of the other vital nutrients. So it's getting a lot easier to understand the entire issue. And we're working hard to now reach clinicians, so we're giving talks with doctors groups at grand rounds and trying to get into major meetings so that the physicians will also understand the issue and be able to advise their patients much better.
Well, yeah, I've never had the pleasure of having whale sushi, but I'll be sure to avoid it if I'm ever offered that.
Somebody told me it actually is tasty, but I think during pregnancy it should be avoided.
So are there any good resources that you can point listeners to that give tables of selenium content in seafood, or any good websites where people can learn more about the mercury selenium issue?
Well, I'll give you our website because we've got brochures and advice pages for both consumers, physicians, and scientists. So you can read about it all three ways. And that's at www.undeerc.org/fish. And that'll take you to a PBS documentary on the issue that's mostly focused on the benefits of the omega-3, but also does discuss the mercury-selenium relationship. But there's also fact sheets and brochures for, like I said, clinicians, dietitians, and the general public to improve their understanding of the seafood issue. It all makes a lot more sense once you've read that stuff.
Yeah.
Otherwise, it's a scary issue, and I can certainly understand why women have avoided eating ocean fish during pregnancy. But now with this, it makes it so much easier and can proceed with knowledge, and that's always a lot better than trying to go on guesswork.
Yeah, I know for me, in learning about toxicity and trying to help people detoxify all kinds of metals and chemicals from their body, my initial consensus, as I was taught, was to avoid fish for the most part because of the mercury toxicity in them. And I did that. I didn't eat that. I still ate a little bit of fish because I couldn't stay away from it, but I was definitely reduced it considerably. And I feel like I really had a devastating effect, so to speak, on my brain function because fish oil doesn't cut it. You're extracting this supplement from a whole food form, and it doesn't work the same as eating a whole food like fish. Yeah. And I really had a huge light bulb moment when I was listening to Dr. Jack Cruz, who's a neurologist, talking about how the omega-3 from fish has very, very different physiological effects, and that it's crucial to eat that to have proper brain function and optimal health. So I think that a lot of the mercury fears are very much unfounded.
Yeah. Well, the one good thing about having your baby brain kind of effect is your body must have been very effectively taking all the omega-3s that your baby needed. It took it away from you, and you took a while to restore it back.
Yeah.
But, I bet your kids are doing fine, though.
Yeah, I did eat a lot of grass-fed meat, though. But it still wasn't enough.
Well, it is one thing too. It's the body is able to make some long-chain fatty acids from the alpha-linolenic acid form. That if it's a grass-fed beef, it will have an omega-3. It's just a short chain. Our bodies are able to add 2 carbon units to that to make the form that's needed for brain, but it's never rich. It's just barely enough, and the beneficial effects appear to accompany having optimal amounts, which is just above minimal. You just want to be in the Goldilocks zone where you're getting enough of all of the nutrients, and not just the omega-3s. Like you said, even taking supplements might not be adequate if other nutrients from ocean fish, like vitamin D. Across North America, most of us are low in vitamin D. We're not out in the sun. We get a little bit from augmented food sources, but really most of us don't get enough. So eating more healthy foods that are nutrient rich, like ocean fish, is something that will be very important for everybody to take into consideration, not only for their own health, but to improve the health of their children.
Yeah, I'm definitely becoming more of a fan of the whole food sources of D, not
Yeah.
the lanolin that have UV rays shined on it to produce vitamin D. It's in a lot
Yeah,
of supplements.
yeah, I agree. Whole foods does make sense. It's what we evolved to deal with, and we're very effective at dealing with what our bodies know how to handle.
Well, Dr. Ralston, again, thank you so much for coming on the show. I have one last question I like to ask all of my guests.
Sure.
What do you think is the most pressing health issue in the world today?
Well, in this case, actually, right now, I got into this issue because I was afraid that women eating ocean fish was causing harm to their babies. Now that I understand the issue better, it took me about a year to catch on to how come, the issue wasn't the way I'd expected. But now what I see as the most pressing issue to take on right now is to get the word out to women that instead of avoiding eating ocean fish during pregnancy, they should increase their ocean fish consumption. Twice a week would be optimal. Most Americans don't even get once a week. The beneficial effects are humongous. I mean, where else can you get 4 to 6 or maybe even more IQ points of benefit for your baby? I can't name a single thing. I want all of the babies that are going to be taking care of me when I'm an old guy needing intelligent physicians to take care of whatever problem I've got to already be there with all of the IQ points they possibly can have. So the urgent issue right now is getting this clarified so that women stop avoiding ocean fish and actually increase their intake, not only for their own health, but for that of their children.
Oh, I love that. Love that so much. Can you tell the listeners a little bit about some of the research that you're doing right now?
Okay, one of the big studies that we're just concluding is looking at the mercury and selenium relationships in ocean and freshwater fish. We're trying to get that published. We've got a nutritional index that is far more reliable. In fact, it's the only index that currently can tell whether ocean fish or seafood consumption is likely to be associated with risks, like pilot whale and shark are associated with risks, whereas other types of ocean fish are associated with benefits. This is called the Selenium Health Benefit Value. We just call it HBV with a subscript SE for selenium. Using that as our criteria, this one accurately and reliably predicts which foods are going to be of benefit to the child outcomes and which ones should be avoided during pregnancy. It completely supports the FDA, EPA advisory about which seafoods to avoid, which ones should be eaten in more abundance. Virtually all ocean fish, other than the ones we've talked about, the shark, the pilot whale, swordfish, and just a couple of other uncommonly consumed types of fish, are the only ones that have negatives. Aside from that, all of the fish, including almost all freshwater fish, have positive values. But moving into the future, we're going to be focusing on that North American sample study, where we'll be looking at the mercury and selenium in lake and river fish, just to establish where there is trouble and where there is not. The nice thing about this is we can rather rapidly alleviate the problem areas by just providing biological forms of selenium. Selenium has to be very carefully dealt with. Too much selenium is not a good thing, just like too much water is not a good thing. It has to be very carefully dealt with, but actually selenium physiology is so well understood that the issues that most people are worried about regarding selenium, most of those had to do only with grazing cattle anyhow. Humans were never at risk of any of those. But looking at ways of alleviating the mercury issue where it does exist, identifying those areas where the problem, might be occurring, getting these things kind of accomplished. That's what are the urgent issues in this meeting coming up next week in Vancouver. It's called CTEC. It's all about environmental chemistry of various toxicants and how to improve the environment. So this is a huge meeting, something like 20,000 scientists gather.
Oh, wow.
Yeah, so I'll be trying to reach every one of them. I won't quite, but I'll be trying to reach them all and get the word out about improving our understanding of mercury-selenium interactions and how to improve the health of the environment by alleviating mercury where it is a problem.
Yeah, you guys are going to be in nerd heaven.
Oh yeah, it'll be great. Yeah, Vancouver's a nice city.
Oh yeah, I love Vancouver. Yeah, so that led me to another question. What forms of selenium do you recommend people supplement if they do?
Well, people that have previously studied supplementation, inorganic selenium can be a bit of a problem. Too much selenium, especially of the inorganic forms like selenite or selenate, those can be problematic, and it's not a problem if you take the right amount, but some people, if you tell them taking 1 is good, they'll take 10 and think it's 10 times better, and that's not a good idea. Yeah. Hardly ever is that a good idea. But if they use like selenomethionine or selenized yeast, those biological forms are a lot safer to take. Even with those, too much is not a good thing. But once again, if you take the recommended amount, which is about 200 micrograms, you're not going to get into the trouble zone. But most North Americans are really not selenium poor. So if people wish to take it just to feel better, they don't even have to take it on a daily basis. One of the wonderful things about selenium is our body, if it's low in selenium, next time it gets any, it'll hang on to it very, very well. So it's not one that we take it in today and lose it tomorrow. If we're low, we'll take it in today and hold on to it for a month. So selenium deficiency is not really a common problem in North America. In parts of Asia, much of Africa, selenium deficiency is a real problem, and it probably is causing severe harm. Low selenium is associated with loss of immune function, and so one of the ways we map selenium in Africa is by HIV incidence. Wherever HIV is high, it's almost always a selenium poor area.
Yeah, because the selenium, it prevents viral replication. So
yeah, it's a very important process, and selenium is important in so many ways. Ebola is even kind of interesting. Ebola expresses a protein that has 16 selenocysteines in it. So when you have a cell infected with Ebola, that cell is being robbed of its selenium. We call this process a selenium theft sequence. And so HIV and Ebola, a few other of the rogues gallery of viral pathogens, seem to employ this way of stealing selenium from the cells. And well, a selenium poor cell is unable to prevent oxidative damage, as we discussed, but viruses like oxidative damage because it enables them to mutate. So a selenium poor cell, like in HIV and hepatitis C, those are two of the famous examples. During the viral replication phase where it's just going into mutational crisis, we think it's because the selenocysteine dependent enzymes have been knocked out, so there's no more protection against oxidative damage. Hepatitis C can mutate by as much as 5% per day during mutational crisis, which sounds like an impossible figure. I have double-checked that figure, and it's like, wow, 5% per day. No wonder our immune system never catches up once it goes bad.
That's why we don't have a cure for HIV or hepatitis C, because the mutations occur too quickly. We can't ever get a vaccine for it or what have you.
It's a challenge, and the interesting thing too is that these pathogens we're talking about, hepatitis C, HIV, and of course Ebola, they evolved in selenium-poor parts of the world, and those parts of the world where the immune system is compromised, it's a great place to spawn new viruses, not just in the humans but also in the wildlife. If you're a selenium-poor macaque or whatever type of monkey, well, you've got poorer abilities to prevent mutation of the viruses that inhabit you. And one of the things that I think in the long term we should be doing is trying to get the selenium status of some of these hot zones of the world up to a nominally okay level. Just bump them up a bit. We might save ourselves a lot of trouble by diminishing the mutation of the next viral pathogen that's going to be causing us trouble. Maybe we should have done this 10 years ago.
Yeah, instead of vaccines, we should be giving selenium.
Well, or along with.
Yeah. I always wondered why a lot of these viruses spontaneously appeared in some of the more tropical regions like Africa, and that's a very good explanation.
Yeah, and it's more than just selenium. I focus on selenium, but iron and copper and zinc are also very important and quite often quite low in those areas. All of them are very important in the immune system, and viruses love to propagate in areas where people don't have a good immune system.
Yeah. Well, Doctor, thank you so much for coming on the show. I really appreciate that. It was a great nerd fest that we had ourselves.
Oh, thank you. My favorite thing.
Yeah, me too. And stay tuned. You guys, if you want to learn all about detoxification and my version of paleo, the modern paleo diet, tune in to live-to110.com. And thank you so much for listening to the Live to 110 podcast. Healthcare regime. And so I'm very thankful for you to, bringing this information to my audience.
Well, we're thankful that you found us, Wendy, and one of the things that that anybody that comes to us through you will receive if they make a purchase is we have a course called Water Magic 101, and it's 30 days of support to support them to immerse themselves in the water. So we don't just want to tell people about it, but if they're